Hello everyone, my name is Nugroho. I want to present my homework 3 number 2 about homogeneous transformation matrices. Let us talk about configuration space first. Robot configuration is a description of every point on the robot, and the space containing all of this configuration is known as the robot's configuration space or C space. This is the robot's configuration is a point in its C space. This is one of the images about configuration space. And uh, for me, I have some confusion about homogeneous matrix. Uh, the first of all, why it use 4 by 4 matrices. Sometimes in the other books we use 3 by 3 matrices. And why 4 by 4? Because the configuration space or C space is non-Euclidean or non-flat. It requires spatial matrices for implicit representation to implicitly represent the configuration of a rigid body. A 16-dimensional 4 by 4 matrix subject to the 10 constraint. And this 10 constraint is adopted. So this 10 constraint is adopted. This matrix expresses the configuration of the body frame relative to the fixed frame. This is the homogeneous matrix. T equals matrix of the first row is R, capital R, and P, and then for the lower matrix is 0 and 1. R represent the rotation matrix 3 by 3. So this is the R, capital R. It consists of R1, 1 and R1, 2, R1, 3, R2, 1, and so on. The P is the column vector of translation vector, P1, P2, P3. The last row, this last row, is used to maintain the homogeneous form and allow translation through the metric multiplication. The reference that I use for the homogeneous matrix is Mechanics, Planning and Control by Frank Park and Kevin Lynch, and also this YouTube channel, Mecha Rhythm Robotics. And for this homogeneous matrix, we have two problems. The first one is rotation about the x-axis by 60 degrees and translation along x-axis by a. And this one, rotation about the y-axis by 45 degrees and translation along y-axis by a. A is a constant. We just put it on the variable. As we know, we will, before we dig deep dive into the solution of the problem, we need to consider to uh, understand this one first. So for the rotation about the x-axis, we will use this template. So this is the template for the rotation about x-axis, and this is the template for the rotation about y-axis, and this is the template for the rotation about z-axis. And for the translation, we use these templates. This is the identity matrix with this is the planar P1, P2, P3, and this is for the rotational matrix as I mentioned in the presentation. So this template is from our beloved Dr. Dekrit Manitam. his book published by C Education Public Company in 2018. This is the problem. I get back to the problem. So this is the rotation along x-axis. So we will use, because this is x, I will use this one. And for the translation, so I will use this template. And for the rotation about y-axis, I will use this one. So after put it, this is the 4 by 4 matrix. The first row is 1 0 0 0. The second row is 0 cosine theta and minus sine theta 0, and for the third row 0 sine theta cosine theta 0, and the fourth row 0 0 0 1. And the other one is like this one, so I need to put this 60 degrees into the theta. So for this one, the first matrix will be 0, sorry, the first row for the first matrix is 1 0 0 0, and the second row is 0 cosine 60 degrees minus sine 60 degrees and 0, and so on. And we know that the sine of 60 degrees are square root of 3 over 2, and cosine of 60 degrees is half, or 0.5. And this one, after we got this one, we translate the sine 60 with this value, so this is the value. And for the translation along the x-axis with a, so this one, the x-axis is a, this one, so this is a, and the other for the b is 0, c is 0. We need to multiply the matrix first from the left hand side, so we need to multiply this one by this one, and after that we multiply the result of this, the step 1 to the this one, and so on. So for the step 1, we need to solve the rotation along x-axis, rotation about x-axis by 60 degrees, and translation along x-axis by a. So we need to solve this one. As we know, the result of the what is it? The result of the multiplication is like this one. So for the first row of the left matrix, we need to multiply the first row to the first column. This is the yellow colored, and multiply by the red column, and we get the result. We put it on the top left position of the matrices. So this one, 1 times 1 plus 0 times 0 plus 0 times 0 plus 0 times 0. The result is 1, and we put the 1 in this area. The first matrices, the first matrix element. And then the first row, like this one. So we need to multiply 1 by multiply by 0, 1 times 0, 0 times 1, 0 times 0, 0 times 0, and the result is 0. So we put the 0 in here. For the on this position, we need to 1 times 0, 0 times 0, 0 times 0, 0 times 0, the result is 0. We put it here. For the last one, the last row, for the result matrix for the step 1 by A, and 0 times 0, 0 times 0, 0 times 1, result is A. We put A in here. So and so on. After multiplication, we have this matrix from the step 1. So for the step 2, we need to multiply this matrix to this matrix. This is the step 2. Step 1, multiply the rotational about y-axis by 45 degree. As we know that 45 degree, we have square root of 2. The sine of 40 degrees same with the cosine of 40 degree, which is square root of 2 over 2. And for the step 2, we have this result. Okay, and then for the step 3, we need to multiply the result of this to this. This is the step 3. From the step 2 times translation along y-axis by 8. This is the step 3, and the result is this one. So this is the final homogeneous matrix from this problem. Rotation about the x-axis by 60 degrees and translation along x-axis by A, and rotation about y-axis by 45 degrees and translation along y-axis by A. And for the problem number 2, we have translation by 3 minus 3 units along x-axis and 5 units along y-axis and 8 units along z-axis, followed by a rotation about y-axis by 60 degrees and rotation about z-axis by 60 degrees. So this is the translation of this problem. We have this matrix. So because x, y, z this is the x is minus 3, this is y or b is 5, and c is x. So this is the rotation along y, rotation around y-axis, so we need to use this template, and rotation about z-axis, we need to use this template. And then after we put all the degrees in the theta like this, and we know that the sine of 60 degrees square root 3 over 2, and the cosine of 60 degrees is 1 and 1 over 2 or a half. This is the sine of 60 degrees is 1 and the cosine of 60 degrees is 0. So the step 1 is we need to compute the rotation about this one, and we get this result. First we need to multiply rotation around y-axis times rotation z-axis. We get this one, And then after that, we can multiply the result from the step 1 to the translation matrix, like this one. And the final homogeneous matrix, the first row are 0, minus half, and square root of 3 over 2, and minus 3. And then the second row is 1, 0, 0, 5. The third row is 0, square root of 3 over 2, 1 over 2, 8, and the fourth row are 0, 0, 0, 1. Okay, this is my explanation about homogeneous matrix. Thank you so much for watching.